The purpose of this lab was to observe motion of an object at constant speed without its direction changing. In order to prove an object's constant motion, Newton's first and second law were used to explain what was occurring in this lab. Newton's first law states that if there is a change in an object's velocity, then the object interacted with something. However, the object will stay at a constant velocity and continue moving at the same speed and direction unless something stops it. Newton's second law relates net interaction between system and surroundings to observe motion of a system where the final velocity equals the initial velocity plus net force divided by mass times delta t. If the net force acting on an object is zero, then Newton's second law becomes Newton's first law, as initial velocity is equal to the final velocity, thus the object will have a constant velocity. I observed the motion of a softball at constant speed without direction changing, which was analyzed by tracker. I started tracking the softball at frame 15 after the ball was initially pushed. When I started tracking the ball, the initial position of the softball is 8.94 times 10 to the negative fourth, and the softball continued to travel in the negative x direction. The softball's position was tracked and plotted using the tracker's graph, where we used the softball's initial position to find its initial velocity. In order to find the initial velocity, I took the first two initial points and divided them by the difference in time, which was initial velocity equals the difference in position delta r divided by the difference in time delta t. I started tracking the softball's motion after the ball was released, thus I assumed the net force was zero and the ball was moving at constant velocity using Newton's first law of motion, where if there is nothing interacting on a softball to change its velocity, the net force acting on the ball is zero, so it will be moving in the same direction and at constant speed. And you can see that my initial velocity was negative 1.354 meters per second. Then I used Python and used my initial velocity findings to input a code to produce a predicted model of softball's motion. I used the starter code given to me for lab, and to make my code correspond with the observed graph that was generated through tracker, I edited the values of mass, initial velocity, and initial position I calculated earlier. As well as I edited the while loop in the softball's mass, changed the net force value to zero to represent zero net force, and the ball was moving at constant velocity. In addition, I updated Newton's second law in the position in the calculation loop. After I ran my program, Python predicted a graph of what the softball's motion was at constant velocity. I combined data from Tracker and Python and used Google Sheets to combine the data on one graph where it compared model position from Python and experimental position from Tracker. The full thicker blue line is the model position from Python, and the red triangles is the experimental position from Tracker. Both models start traveling at the same rate, and around 4 times 10 to the negative 1 seconds, there's a change in the experimental position where the ball began to drift. Other than the drift, Tracker's data still represents softball moving at constant velocity. In the first discussion question, if I flip the axis moving in the positive direction, the graph would be in the first quadrant with a positive slope, and the ball would travel at the same speed, and the direction would be different than the original model due to moving in the positive x direction. For the second discussion question, there is not enough information to determine the number of pushes and pulls adding together to give the system a given zero net force. Newton's first and second law states if the net force equals zero, it's easier to update the velocity as the initial position is zero because the object is moving at constant velocity. The law explains that the object travels at a constant velocity because interaction on the system add up to zero. Thus, the velocity of an object will be constant because there's no interactions acting on the system to change its velocity.